Do you have any other questions? When is your NSEM exam, by the way? September
And
3rd?
1st September.
1st of September. Oh, it's nearby. As I said in the previous live session, NSEM will contain 75% of questions from Laplace and Fourier transform. Okay, be prepared for that.
Ma'am, uh,
Yes.
professor solved an example to find linear transformation of e to the power minus at ut.
Linear
Could you?
transformation.
Sorry, Laplace transformation.
Okay. Are you talking about this?
Uh, e to the power minus at.
Okay. Is this
And
the?
then yes, and he also solved for ROC for this signal.
Yes, Tushar. I started recording the signal. Let me open the lecture notes. See, as I said, remember certain things. ROC of right sided signal is right to the rightmost pole. Okay, and how do we solve for x of s? X of s is minus infinity to infinity, e power minus at u of t, e power minus st dt. What is this? Integral minus infinity to infinity, e power minus a plus s t u of t dt, which is nothing but integral 0 to infinity e power minus a plus s t dt, which is e power minus s plus a t by minus s plus a 0 infinity e power minus infinity divided by minus 1 times s plus a e power 0. Correct? So let's first plot the pole 0 plot. So for the given signal, there are no zeros. The numerator do not contain any s parts, so there are no zeros. For the pole, how do we find? Equate s plus a to be equal to 0. So s is minus a. So there is only one pole, which is minus a. And what is the region of convergence? As you could see, the given signal is a right-sided signal. Why? When you plot the signal, it looks something like this. It's not defined on the left plane, right? U of t is there, it's not defined. So this is a right-sided signal. When the signal is right-sided, the ROC is right to the rightmost pole. There is only one pole, so it is right side. I mean, I should not draw like this. Don't know where this option went away. Oh, yeah, should actually draw it like this. The ROC contains all strips to the rightmost pole. So this entire thing is the region of convergence. So the region of convergence is given as a real part of S being greater than minus A. Is that right? Hello?
Yes, ma'am.
Yeah, this is how you are supposed to solve. Suppose if the given signal is a left-sided signal, then the ROC is left to the pole. If it is a causal signal, the causal signal is defined only on the left side of the plane, right? Why? For the causal signal at any time t, it only depends on the past values. So the ROC is always contained. So, or maybe, yeah, am I talking something wrong? Okay, I don't want to talk something. Yeah, but yeah, the 2 points are for any right-sided signal, the ROC is always right to the rightmost pole. For any left-sided signal, the ROC is always left to the leftmost pole. Neither right nor left, the ROC lies in between the poles. Okay, and there are also a couple of points that I would like to make. Just a second, let me open my notes. For a causal system, ROC is again right to the rightmost pole, and for any bibostable system, ROC should contain j omega axis, where j omega is this. So it should contain, or otherwise it should contain, for any bibostable system, the ROC contains sigma equal to 0. Okay, so yeah, these are certain points that you should note. Okay.
Yes, ma'am.
Any other questions? One more thing that is important from Laplace transform is this initial and final value theorem. And what does this say? Uh, if any given signal is right sided, in other words, x of t equal to 0 for t less than 0, then one is the initial value theorem, which tells that limit s tending to infinity. Sorry, like, why has nobody told me to put my, yeah, limit s tending to infinity, s times x of s is limit t tending to infinity x of t, sorry, t tending to 0. What this means is limit t goes to 0 x of t is, other words, like what we mean by x of 0. So the initial value of the signal can be calculated from the Laplace transform by evaluating this limit. So that is what uh, initial value theorem states.
Ma'am, I
And
think S also tending to 0.
no, no. So initial value theorem states, let me represent it by IVT, initial value theorem. This states limit t tending to 0 x of t, which is x of 0. This is limit s tending to infinity s times x of s. And there is other thing, final value theorem. This tells x of infinity, which is limit t tends to infinity x of t. This is limit s tending to 0 s times x of s. Okay, don't be confused. Very important theorems. Is that all right? Yeah, these things are also important. And what else? Yeah, other things pretty much the same. You just need to solve more and more problems. Okay, please solve your assignments. Lecture notes is uploaded, MATLAB code is uploaded. I think everything is in your code now. Any more questions? If you have any questions, you can stay, otherwise, we can wind up. Okay.
Yes, ma'am. I have no questions.
Okay. Yeah, please watch your lecture videos, do your assignments, okay? And then, alright, so can I just end the session?
Okay, ma'am.
Yeah, thank you for attending. Yeah, bye.
Thank you.